This is the procedures video for SCT 151. Let's start off with the definition. This is something you need to have tattooed in your brain that you can never ever forget. Procedure is a short, named group of commands designed to complete a specific task. Now there are two types of procedures, subroutines and functions. Subroutines do work, functions do work, and return a single value. Why are procedures beneficial? Since ancient times, the strategy of divide and conquer has been used to solve complex problems. Procedures allow you, the programmer, to break up large complex problems into smaller, more easy to manage problems. And trust me, that's a good thing. Another benefit of procedures is that you can reuse them. You can write the code once and call it many times. Procedures are also reliable. By creating and using procedures, you make your code easier to debug and maintain, since the code to complete any specific task is in just one place. Sounds completely logical, doesn't it? Now let's go back and examine that definition one piece at a time. First off, what do we mean by short? Now, I want everyone to do a little experiment, play along with me here. I want everyone to write down on a scrap piece of paper or notepad what your definition of short is. Go ahead and pause the video until you've gotten that written down. And I'm serious about this. It's important. I need you to actually type or write something down. It's very important. Now go ahead and pause the video, write down what you think the definition of short means. You will now pause. So most programmers usually give one of the following answers or something close to it. Only as long as it needs to be, sufficient for the task, and not too long. So I'm guessing some of you folks probably had something like that, or maybe a specific number of lines. Now, pretend I'm your manager at some company, and pretend we're all sitting in a room. I'm addressing the entire programming department, and I say something like, "Hello everyone, we're getting too many bugs in our software, so I have to come up with a solution. I want you to all write short procedures." And I say that in a very commanding, Darth Vader type voice. Now, what effects would that have? I bet everybody in the room would nod their heads, stroke their beards wisely, "Oh, yes, of course," and make general murmurs of assent. Yes, of course, yeah. However, not a single programmer would do anything differently, because right now all of you write programs that are only as long as they need to be and sufficient for the task and not too long and other stuff like that there. So me standing up as a manager or even trying to make a coding standard like that is completely and totally useless. Now, why wouldn't a single programmer do anything differently? Because the definition of short is too vague and arbitrary. How many of you, and I want you to all raise your hands, how many of you have ever written more code than you needed? How many of you may have ever made a procedure that was too long? All right, not many people are willing to admit that, and I can't once remember writing more code than was needed for the task. That's why defining short in arbitrary terms doesn't do any good. We need something more concrete. A lot of times programmers will then try to define it as 15 or maybe 20 lines long. That won't work either, because then programmers have to count lines. And there'll be a line counting Nazi out there that will say your procedure is bad because it's 21 lines long, something horrible like that. Besides, that is just an arbitrary rule that makes no sense. Where did you come up with 15 or 20? I used to look at this problem from a programmer's perspective. Then I became a manager and I started looking at the problem from a manager's perspective. Actually, a manager programmer's perspective. Managers have to be concerned about the long-term maintenance of the application, whereas most programmers are concerned just about their particular part. Manager realized that several different people might work on the same application over a period of years. If a programmer can't understand the code, he'll have to rewrite it. This happens all the time in the business world. Sadly, much of the time when the code is rewritten, the programmers doing the rewrite break the same coding standards as the programmers that wrote the original code. They make the exact same mistakes, and the end product can be understood only by those who wrote it. For a manager and a company, this is unacceptable. So, we need a definition for short that is easy to apply and helpful. It's got to help us reach our goal. So here's the definition. Are you ready? 1 page or screen or less. Why 1 page? Because you, the programmer, can easily see and therefore read and therefore understand all the code for a particular procedure. If it's longer than 1 page, you can't see it all and you can't read it all. Any programmer with a reasonable amount of skill should be able to easily write all the code for a specific task in 1 page or less 99% of the time. It's a very rare exception when a procedure needs to be longer than a page. So, if you have a procedure that's longer than 1 page, you'll need to break it up into 2 or more smaller procedures. You'll keep dividing the logic until each piece is less than 1 page in length. I call this coding standard the 1-page limit. You will learn to do this, and you will lose points if you write procedures that are longer than 1 page. Now, most new programmers instinctively understand and take this coding standard to heart. Most experienced programmers fight me like crazy on this. Now, why do they fight? Because I'm forcing them to change their coding habits. What I'm basically saying is I want you to do things differently. And habits can be very hard to change. Now, one danger with coding is that we get set in our ways. It's important to stay flexible and keep an open mind, especially for logical reasons, or when logical reasons have been presented for you to change the way you do something. There are many reasons for writing short procedures. Readability is by far the most important of those reasons. But keeping your procedures short also puts you in a straitjacket. It's hard to make a mess because you don't have much room to make a mess in. It's like your dad telling you to put away your toy before you get out another one. You will not make a mess of the family room with 20 plus toys. You get one to play with at a time. I'm sure every experienced coder out there can tell you horror stories about the project he or she was on that had mile-long procedures and how it was a tangled mess of spaghetti code. The 1-page limit is pretty effective at preventing that from happening. It's easy to understand and intuitive to use. I still get complaints from experienced programmers and sometimes new programmers. My reply is this: look, as an information technology professional, getting paid over $45,000 a year, and that is starting salary, this is one of the things you just have to deal with it. Accept it and move on. You'll be a better programmer for it, you'll write better code, and your team members and your company will appreciate you more for it. You get to assign a name to every procedure you make. That name you assign is extremely important. It should tell the reader exactly what the procedure does without having to look at the code. Naming procedures and variables well is a skill that you have to develop. All right, it's something you got to work on. For many programmers, it does not come naturally. Sometimes even me, have to sit back and think for 20 or 30 seconds what to name a procedure, and I've been doing this for almost 20 years. A great way to test if your procedure is named well is to show the name to a coworker or friend and ask them to tell you what the procedure does. If a friend or coworker can't give you a good answer quickly, guess what? You need a better name. When naming procedures, we follow some of the same coding standards as we do for variables. First off, proper case. So we capitalize the first letter of each word. For example, add two values. The A in add and the V in value is capitalized. There are no abbreviations. No abbreviations. No calc tote, no get max, none of that stuff. And descriptive. The procedure name must be descriptive. Now, for functions, I do not use prefixes. I get asked this question sometimes because you can pass in variables by reference. And so you could potentially change and return multiple values by reference. And so in that case, prefixes don't apply. Also, most of the times with the autocomplete, you get to see the return data type. So I do not recommend prefixes for functions. Now, there's the letter of the law and there's the spirit of the law. In one of the upcoming homeworks, I'm going to ask you to write a procedure that will add the whole numbers 1 to 100. Again, that's going to be in a procedure. Now, most programmers give the procedure the name add numbers 1 to 100. Now, the open and closed paren means it's a procedure, not a variable. And that name is fine. However, a few problems later, I ask you to write a procedure that will add every 7.54 number from 4,923.53 divided by 51.34 to blah, 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 blah. And about 2 or 3 out of every 20 students comes up with this procedure name. Just look at that. Wow, that's a big one. And now it's funny, when I go to have people turn in the homeworks, I ask for volunteers to tell me who did this, and I get 1 or 2 that sheepishly raise their hand and a few that smile and look down that don't raise their hand. Anyways, that does follow the letter of the law, but it does not follow the spirit of the law. By not abbreviating and trying to be descriptive, you actually hurt readability. That's gone too far. Now, a much better name would be add decimal numbers in range, or I like to joke, add Pat's crazy decimal numbers. Now remember, it's the spirit of law that's important, not the letter of law when naming things. Years and years ago, in 1998-ish, my instructor in high school told me a procedure should do one and only one thing. I still remember him saying this, and I took that advice or instruction to heart, and it worked really, really well. It's been a huge factor in my success as a programmer. After years of practice, I'm very, very good at writing procedures that do one and only one thing at a time. I'm great at dividing and conquering, not only in programming, but just in about every area. Any logical discipline, I can chop it up. However, it's taken me years to appreciate just how wise and beneficial that simple little statement really is. And I'm sure I have not yet plumbed the depths of all the wisdom contained in it. I could write sonnets and poetry on how beneficial, amazing, and wise single task procedures really are. So, make sure your procedures do one and only one task. Now remember, it's the spirit of the law rather than the letter of the law. Don't write 3 procedures to break up the following line: in average equals 2 values divided by 2. I've seen people take it to extreme. But your procedure should pretty much do one and only one thing. If you do that, you will go far. Here's one of the things I've hardly ever seen in a book. Anytime you find yourself writing the same code more than once in the same programming, a little warning indicator on the computer console in your brain should start beeping and flashing. If you have the same code in 2 spots, you need to stop and do one of 2 things. You should loopize the code, or you should procedurize the code. Now, we'll focus on just procedurizing the code here, but you should take the duplicate code, put it in a procedure once, and then call it from however many locations you need to. That's a very, very important habit to get into. Why? Because when you change the code, you'll have to change it in only one place. Your programs are small now, but just wait until you get into a 10 or 20,000 line program. You'll be happy that you have the habit, and that your code for each task is in one and only one place. Okay, this is really important. Pay attention. Procedures should appear in your code in the order that they are called. Now I want everyone to say that with me, and I'm serious. Procedures should appear in your code in the order that they are called. Why? So you can read through the program from top to bottom and left to right, just like you would read a book. You want to be able to read through the code at 60 miles per hour. If the procedures are not in the called order, you have to page up and down and bounce around in the code to follow the logic. It's very easy to get lost that way, and I'm sure you all know what getting lost in code feels like. Now, I will take off points if your procedures are not in the order they are called. By the way, that goes for your VB.NET code too. The first procedure should be form load, followed by anything called to form load, and next you should have the control events, and so on, top to bottom, left to right. Now don't forget, I allow resubmit, so when you make mistakes, I'm going to mark it wrong, and you'll get at least one chance to fix it. That's if I teach the class. Remember, I supply the content for this class, but I do not always teach it. So check the syllabus to make sure that your instructor allows resubmits for a full credit. I'm trying to develop good coding habits in you. Why? Because when you transition from small programs in the classroom to medium and large programs in the business world, you'll have the same programming habits. Now, there are some things you can get away with on small programs, but if you do those same things on large projects, you will fail. Now, you may get stuck and or lost and never be able to finish the project. Now, this is a very real danger. Now, think back to VB.NET number 1. Did you ever get stuck on a program and you couldn't figure out what to do next? Well, that doesn't happen just in school. It can happen in business too. At my last job, I inherited an existing application when I started. It took me 3 months to figure out what it did, and I was not slacking. I was going toe-to-toe with that monster every day, duking it out. Now, my first week, I just read code for 40-plus hours, trying to figure out what was where, and it was a mess. Now, imagine you come into a job, and you sit down at 8 a.m., and you read code for the next 8 hours, and you have a nice little hour lunch break, but you read through it and you're trying to retain it all in your head, figure out where all the pieces are, and then do that for 5 whole days. And I barely scratched the surface. Now, around the 4 or 5 month mark at my last job, I spent 40 plus hours making a single change. Now, I showed it to another coder that used to work there. He had left and gone to a consulting company, and we temporarily hired him back, which proves you can jump from the frying pan into the fire. So he looks at the code that I've written and says, no, that's wrong. It should be handled over here. I'll do it. So I lost 40 hours of work because of my lack of knowledge of the code, because it was such a giant mess. Let me tell you, I was mad. So yes, I am literally trying to brainwash you into good coding habits. This is the way you want to code Jedi Handwave. Now trust me, in 5 or 10 years, you'll be thanking me for all these wonderful habits. That's also one of the reasons co-op employers like to get my recommendation for students, because they know I've already broken you in. They have to do less arm wrestling. They like someone who follows directions and writes good, clean code. There are 3 steps to creating and using procedures in C. You define, that's where you write the actual procedure code. Then you declare it to tell the compiler what to expect, and then finally you call it. Let's examine those steps one at a time. In order to define a procedure, we have to know the syntax. The generic syntax for a procedure in C is a return data type, followed by the procedure name, followed by one or more optional parameters or in parentheses. Again, those are optional. You do not have to have parameters. Then an open and closed curly brace or curly brackets, and in between those, one or more commands. The return type can be any valid C data type, short, int, long, character, double, float, whatever. Use the data type void to indicate that the procedure is a subroutine and that it does not return a result. So for example, here we have void and then display instructions. Notice proper case, prefix, proper case, descriptive names, no abbreviations. Now the open and closed parenthesis is what tell us that this is a procedure and not a variable. We've got our open and closed curly brackets, and then inside one or more commands. Use any other data type to indicate that the procedure is a function. If it is a function, it must return a value. Now use the return keyword to return a value. So for example, a very simple function here, float get pi, and we return 3.14159. Notice I cast it to a float, and we've got the return keyword. Execution of the commands in the procedure stops as soon as a returned command or keyword is encountered. So for example, if I added the line printf, this message will never be displayed, it will never get executed, because as soon as that return statement happens, boonk, the program stops. Or I'm sorry, the execution of the code in that procedure stops and returns to the calling procedure. Now, by the way, you get one and only one return statement per procedure. I see this really terrible habit of programmers. They have multiple returns in there. I'll talk more on that later when we get in passing parameters and stuff, but you get one and only one return. Now we understand why there's always a return 0 in the book examples for main. So you can see main is defined as an int, so it's an integer function, and they always put return 0 because you must return something. This value returned is supposed to be a result code. If the value is 0, or if a value of 0 is returned, then the program executed and terminated normally without any errors. If a non-zero value is returned, then the program encountered an error. The value returned is supposed to be an error number that tells the calling program what happened. This is hardly ever used anymore in a Windows operating system. It's mostly used for programs that run on a Unix platform. I find it makes no sense to have an integer function that always returns 0. That's why I change it from int main to void main, so that I don't have to return a useless error code value. Now some compilers, as in Visual Studio, may require you to have int main and return 0 even if you don't need it. That's fine. Just go ahead and do it in there. Remember that before your program can run, the source code must be translated into machine code. Compilers and interpreters are 2 types of programs that translate source code to machine code. Compilers save the results of the translation in a file. That file is usually an executable file with a .exe extension. The C language uses a one-pass compiler. Programming languages like VB.NET use a two-pass compiler. Two-pass compilers are much easier to use. The first pass of a two-pass compiler looks for all the procedures and a few other things. The second pass of a two-pass compiler then compiles all the code, and it can resolve the calls to any procedures because it already has a complete list of them that it got from the first pass. If it finds a call to a procedure that's not defined, it will display an error message. That is very, very nice. We all love VB. Everyone give VB.NET a hug. One-pass compilers make only one pass through the code. They start at the top and read one line at a time all the way to the bottom. In order to call a procedure, when you're dealing with one-pass compiler, you must do one of two things. You either must define the procedure before you call it. That means the procedure must be physically above the call in the code, so that determines the physical order. Or you have to declare the procedure at the top of the program to let the compiler know what to expect. Now, option A is not valid for us because that means the main procedure must appear last in the physical order all the way at the bottom. That means you'll have to read the code from the bottom up, which is not intuitive. So we'll need to use option B so that our procedures can appear in the order that they are called. Yeah, I'm starting to like VB more already, don't you? Yep. Now, I'm sure one of you out there is asking, well, that's stupid. How come C doesn't use a two-pass compiler? It's a very good question. Because C assumes you are the expert. Remember, language is all about control. It shouldn't have to do anything for you because you must have some limited resources that needs to be controlled. If you don't have a limited resource, then how come you're using C? If you want a language that does something for you, C is not the right one. Now, this is not a bad thing. That's the way the language was designed. You don't say motorcycles are bad because they have just two wheels and don't have a reverse gear. That's the way we're designed. It's the same way with C. It's a lean, mean coding machine. You're supposed to use it when you have a resource problem that needs a serious level of control. Now, declaring your procedures needs to be done at the top of your program so the compiler knows what to expect when it reads through the code. So it's like making dinner reservations. You tell it what's going to be happening and how many guests are coming, and it's happy to go out and buy the food and prepare it all. You just need to tell it ahead of time. So our code template from the coding standard document looks something like this. We got our name, class, abstract, block. We got our includes, constants, user-defined types, and prototypes. Right here you can see a comment block, and that's where all our procedure declarations go. All right, so we're going to be putting them between the prototypes and between main. A procedure declaration is just the first line of a procedure, the return data type, the name of the procedure, and then the optional parameters in parentheses, followed by a semicolon. Now, for example, if we have the following procedure definition, void display instructions, open curly brace, printf, close curly brace, the declaration that we have to give to the compiler is void display instructions and semicolon. Notice the semicolon at the end of the declaration, but not at the end of the definition. Now, here's what that code would look like in Visual Studio. So here we are in Visual Studio with the code template copied and pasted in. I've got main with a call to the subroutine display instructions. Now, why is it subroutine? Because the return data type is void. Boy, that sounds like a great surprise unannounced quiz question. I got a single printf in there, and I try to go ahead and run this, and it should give me an error. We got an error. Display instructions redefinition. That's C's ways of telling you that it doesn't like the procedure, and that's because we didn't tell the compiler what to expect. Now, what we could do is we could move that code for display instructions above the call. So this is the definition. And down here, this is the call. Now we can do that, and that'll work. But the problem with that is, then the code is the procedures are not in the order that they are called, which makes it harder to read. So what we want to do is we want to put the definition in the order it's called, right after main. And then we come up here, copy that first line, paste it in the prototype section, and throw a semicolon on the end. Now we have correctly declared it after we define it and call it, and it works as we want it to. So this is the declaration. Tell compiler what to expect. Now a lot of times you are going to get errors because you are going to have a typo. You'll have display instruction, and you'll have display instructions down here, and that one letter difference, the compiler is looking for somebody else on the guest list. As far as reservations go, there's a Mr. Instruction, not a Mr. Instructions, and it will not work. So let's go ahead and run that, and you'll love this cryptic error. What is there? Display instructions redefinition. Yeah, that's totally and completely obvious, right? Usually when you get an error like that, what it means is you try to call something and the call or the definition name or the declarations do not match. One of those three does not match the others. After you define and declare a procedure, you can call it. The syntax to call a procedure is just the procedure name followed by parentheses and values or variables for any parameters inside those parentheses. So just to recap, here's your declaration, there's the call, and there's the definition start, and there's the definition end. If it's a function, you can use the assignment operator to assign the return value to a variable. So for example, we have our declaration getPy, we have void main, and in there I declare a variable pi, and I call the function getPy, and on the left side of that function I have the assignment operator along with the variable. So this value, whatever is down here, will be stuffed into that variable when we're all done. Now the call is the easy part. Once you write the procedure, define it, and then tell the compiler what to expect, declare it, there isn't much left to do. But still, the declaration part is a step that you probably aren't used to doing, but you'll soon learn the habit. Again, that's why I like to call C VB appreciation, because the more I use C, the more I like VB. Indentation. Always indent the code inside your procedure by one and only one tab. This is called indenting to show scope. Don't do this. See, up here the code is not indented. Here it is indented. It is indented one tab. So everything between the open curly bracket and closing curly bracket get indented one tab. If you have an if statement or a loop inside the procedure, the code inside the if or loop brackets gets indented too. So for example, everything inside this procedure from the beginning to end is all indented one tab. Everything inside the the if statement is indented one tab, and same with everything inside the for loop. Again, this is called indenting to show scope. And why do we do it? Readability, so you can easily tell where each block of code starts and ends. Opening brackets should always be on a line by themselves, and the closing bracket should line up vertically with the opening bracket. Why? Readability, of course. This is a hard to read example, and you see this all across the internet and in the book and everywhere. They put the open bracket at the end of the line. See, right? There's three of them. That makes it difficult to match up which opening bracket goes with which closing bracket. Now here's the easy to read example. Notice you can draw an imaginary line from the starting bracket to the closing one. It's much easier to read and tell where things start and stop. It's basically like your HTML code if you've taken that. Every start tag should match up vertically with just about every closing tag, and you want to be able to easily tell where it starts and stops. This helps for readability, debugging, sanity, makes the grader happy. Yeah, you don't want angry grader syndrome, so make sure your starting bracket is always on a line by itself and that the closing bracket lines up vertically with it. Again, from a manager's perspective, it's important code be easy to read so that it can be easily maintained throughout the life of the application. So for all the important procedures, you'll make a comment block like this. So you got dashed lines, name, and abstract. And when you're writing the abstract, you get 1/2 to 2 lines at most usually when you're writing that description. Now the purpose of the comment block, as I talked about in the homework videos, is to describe what the code does in English. That way you don't need to look at the coding details to understand the logic. This allows the programmer to read through the code very quickly. Oftentimes, the abstract is simply the procedure name with spaces between the words or close to it. So if the name of the procedure is add two values, then the abstract might be add two values and return the total. You get 1/2 to 2 lines to describe what the procedure does. If you can't do that for the vast majority of procedures, there's a problem. Maybe the procedure name does too much, or maybe the procedure does too much and needs to be broken up. Maybe you don't understand yourself what the procedure does. If that happens, you need to rewrite it. Maybe you aren't good at describing in comments what you did in code. That's a skill that you're going to have to develop, and it's a very important one too. If you write more than one line worth of comments, you'll quickly dilute the value of your word. After 2 or 3 procedures, other programmers will stop reading your comments. They've already determined that it's faster to read the code than your comments, and that's not a good thing. As you gain experience, you'll find that the comment blocks start coming first. You write down what you want to do and think about it. This will help you plan your code better. You will have less problems and you'll work faster. It's best to start this habit sooner rather than later. Now, writing procedure comment blocks and planning what you're going to do first helps to prevent you from getting emotionally invested in the code. That means when you have to make changes, you'll be more easily able to adapt. So if somebody comes along and says, no, that's wrong, delete it, you're like, okay. As I stated earlier, all important procedures get a comment block. Now pretend we're all sitting around in a classroom. I have a list of 100 procedures. I hand that list out to all the students. I ask each student to mark which procedures he thinks are the important ones. Do you think I'll get the same answers from every student? Of course not. Now let's look at that from a manager's perspective. I need to define a set of criteria that students and programmers can use to determine if a procedure is important or not. I'd like you all to pause the video and try to come up with a set of criteria that can be used to determine if a procedure is important. Write your answer down on a piece of scrap paper or a notepad or something. Now it's important that you actually physically write something down. So go ahead and pause the video and do that. Okay, we're back and you should have written down criteria somewhere. Hard, wasn't it? We want something that's easy to remember and apply. In addition, we must get consistent results from all the programmer using it. Very challenging indeed. Now, lots of programmers give me answers like this. If the logic is complex, it gets a comment block. Okay. If it's not easily understood, it gets a comment block. The programmer should use his or her best judgment. If it's more than 10 lines of code. If the procedure does something special. That's one of my favorite ones. The problem with all those criteria and others like it is that they are all random and subjective. We want something that's orderly and objective. Any ideas? The answer is on the next slide. The answer is all procedures are important. If it's not important, it should be deleted from your code. So all procedures get a comment block with the following format. Now I want you to copy and paste the comment block out of the coding standards document and use it everywhere. Now don't replace the dashes with equal signs or asterisks like I've done here and here, or make the comment lines longer or have different lengths like here and here. Notice this one ends here and this one goes on here. Because when you do that, basically what you told your manager is, hey, I don't like the comment blocks you're providing and the rest of the team is using. So instead of me adapting to you people, all of you are going to have to adapt to me. Now, in a war between you and your boss, who's going to win? Yeah, that's right. Let's talk about spacing. Do not put a gap after the comment block but before the procedure. See right here? No gap. There is no gap there. No gap. However, and I'm still going to get people to put a gap there, everybody repeat after me. There is no gap after the procedure. I'm sorry. There is no gap after the comment block before the procedure. However, there are 3 blank lines after the end of one procedure and the beginning of the next. All right, everybody got that? No gap and then 3 blank lines. Whew, we finally made it to the summary. That was long. So, a procedure is a short named group of commands designed to complete a specific task. The benefits are that you can divide and conquer complex problems into smaller, more easier to manage problems. You can reuse code. You get reliability because the code is only in one spot, so if you have to fix anything or make any changes, you just have to do that once. And over time, you'll eventually get all the bugs. And then readability, that's the procedure name. You get to take a bunch of commands and then give a nice, easy to read name on that. Now, when you're making the procedure name, you want to use proper case, no abbreviations, and descriptive names. Coding standards. It should be short. That's 1 page or less. It should do one and only one thing, and they should be in the order that they are called. There are 3 steps to using procedures in C. First, you have to define it. Then you have to declare it, tell the compiler what to expect, and finally you can call it. Now the prototype declarations tell the compiler what to expect, and that is what allows us to put the procedures in any order that we want. And all important procedures get a comment block. And that is the end of the video.